Feel for what we mean by probability and some basic terminology. We're going to continue with that idea of basic terminology and some definitions here. So the first section, I want you to notice that up here we have keywords and then the rule of probability. So I think sometimes the part that confuses people is knowing what formula to use where. So important to associate keywords with each of these. Now the first one, I call this rule 0 because it's not really, hopefully it's something that you already know and it's not per se a formula, but we need to know this idea that when we calculate a probability, so the probability of some event A could be lots of things, so probability of this thing A happening, when we calculate that, we should always get numbers between 0 and 1. So use this as a check as you're working through later problems. If you get a number that's outside of 0 to 1, you know you've probably made a mistake, corresponding with 0% chance of happening all the way up to 100% chance of happening. Now the next one is this idea of complement. And this should be something you're familiar with as well. So for example, if I said there's an 80% chance of rain, and I asked what's the chance of no rain, right, hopefully you're all saying 20%. So this idea of complement is finding the outcomes not in A, so I'll write that over here for our keyword, the probability something does not happen, or the opposite of something happening. And complements also need to add up to 100, just like the 2080 example we just did. So our rule or formula for this one is going to be the probability that A does not happen. So notice I'm using the superscript C here to mean the complement or does not happen. If you've seen this before, you may have seen it as a little tick mark, like a prime or a line over the A. There's different ways to write it, but I'll use this superscript C. So probability A does not happen is 1 minus the probability that it does. That's exactly what you guys did to tell me the probability of no rain if there's 80% chance of rain, 20% chance of no rain. You just did 1 minus. Okay, so let's do an example of this using the data set that we developed in the last video. So we've got our event A before was tails, tails. So I'm going to draw a Venn diagram representing my entire sample space here. I'll put an S to say this represents all 4 of my outcomes for tossing a coin twice. Event A had the values of tails, tails. And I still have all these other options, tails, heads, heads, tails, and then heads, heads. So if I'm curious about the probability that A does not happen, that means I'm interested in not this little circle with A, but all this other stuff outside of A. Shading in, sorry this is bad shading, but shading in all this other part, everything except for that circle of A. So the probability that that happens is 1 minus the probability of A, according to our formula, or 1 minus, and the probability of A was 1 out of the 4 outcomes, which leaves me with 3/4, which makes perfect sense. We see we shaded in 3 out of the 4 outcomes when we represented not A, or the complement of A. All right, the next definition is this idea of union. When we're talking about union, think of this word or. So means all the events in one or the other, or maybe both. So another way to say that for our keyword here is at least one. Okay. So one or the other or both, meaning or at least one. And let's do an example using some of our events that we had before. So let me draw our sample space again. And this time I'm going to highlight the events B and C. So B, label this here B, was that one of at least one head. So it had heads, tails, tails, heads, and heads, heads. And then C was the event that had exactly two heads. So there's heads, heads in that circle, and I still have tails, tails floating around out here. So if I'm talking about A or B, that's our key word. So union means A or B, or maybe both. Our symbol for that, be comfortable with just using the word or. Also be comfortable with the symbol. It looks sort of like a U for union. So A or B. Those mean the same thing. And if I'm thinking about shading this, I'm shading everything in one circle or the other circle or both of the circles. All of this stuff, one or the other or the both. And you'll notice in our example, everything in one or the other or both consists of heads, tails, tails, heads, and heads, heads. Okay, so that's what we mean by union or, one or the other or both. Next bit of terminology is this idea of intersection. An intersection must be in both of these things, strictly speaking. So think of union as or, intersection is this both or and part. So intersection must be in both of them. There's our key word is and. So again, I'll draw the same picture for comparison. We've got our event B with outcomes heads, tails, tails, heads, heads, heads. And we've got our event C with heads, heads. We still have tails, tails out here. So our notation, we're going to write A and B. Again, be comfortable with the words or be comfortable with the notation. So this notation is going to look like that upside down U, or I suggest remembering it as this kind of looks like an A without the line through it for and. Okay, so A and B, you also read this, A and B. And the outcomes that are in both A and B in this example must be in both. The and, the overlap, is just this middle part, the heads, heads. So intersection is just like it says, where they intersect, that overlap. Union is one or the other or that overlap. All right, the next idea or definition we have is this idea of disjoint events. Disjoint just simply means we have no common outcomes or their intersection is empty. This overlap has nothing in it. So another phrase for disjoint is this idea of mutually exclusive. Okay, so when we say mutually exclusive, that's a synonym for disjoint. Be comfortable using those words interchangeably. They mean the exact same thing. So disjoint events have no common outcomes. If we want to think about an example from our set of 3 events that we had earlier, events A, for example, that one had the outcomes of tails, tails, and B, A and C, well, I guess I could do B as well, that one works. B had the outcomes of heads, tails, tails, heads, heads, heads. They don't share any, there are no shared outcomes, nothing in common. There's not an outcome that's both in B and in A. So here I might say A and B, their intersection is empty. There's nothing in common between these two. Up here we had heads, heads was common between them. Down here there's nothing common between these two events. So we would say A and B are disjoint or mutually exclusive events. Just a little catch up here. If they're disjoint, then what do we know about their probability of the intersection? Remember this idea we had before, number of outcomes in the event over total number in the sample space. So I've got four different arrangements when I toss the coin twice. A and B have nothing in common. This is empty, there's nothing in there, so I'm just going to put a 0 here. So if there are two events that are disjoint, then their probability of their intersection is 0. Take a look at your events A, B, and C and see if you can find another pair that's considered disjoint. Right. A and C are also disjoint. A was heads, heads, A was tails, tails, C was heads, heads. They don't share anything in common, so those are also disjoint. All right, let's check out the addition rule. So our next kind of formula here. And addition, you want to associate with unions. So or at least one. And I'm going to give you this general rule. It works for any events A and B when we're interested in the probability of the union of those. So here's our rule, probability of A or B, that's our union. And like the name suggests, addition, we're just going to add those together, probability of A plus probability of B, and we're going to subtract that overlap or what they have in common, A and B. So let's take a second to kind of see why and convince ourselves of that formula. So maybe let's do an example using those events B and C that we had earlier. So here was B with our heads, tails, tails, heads, heads, heads. C also had that heads, heads, and then I've got tails, tails hanging out around here. So notice I'm going to change the letters now to be B and C because those are my two events that we're speaking about. So B or C. The rule says to start by adding those probabilities together. So probability of B plus probability of C. So probability of B was 3 out of 4. I have 3 out of my 4 outcomes in event B. C, I've got 1 out of my 4 outcomes in C. If you think about the picture and what we've added this entire circle of B together, and then I've also added this entire circle for C together. And you'll notice when we did that, we counted this middle part, this overlap, 2 times. We counted it once with B and once with C. So since we don't want to double count, we better subtract that 1 time so we're not double counting. And if you think about our formula, if we didn't have that value on there, 3/4 plus 1/4 would give us probability of 1, which we know is not correct because there's still another outcome here that's not included. So we need to subtract that overlap, B and C, so we're not double counting it. That overlap of B and C has 1 outcome out of the 4 possible. So now we get 3/4 for our final answer, which makes perfect sense. I've highlighted 3 out of the 4 total possible outcomes. All right, a couple more and then we'll take a little bit of a break and look at some examples. The next one is addition rule, but it's a very specific one. It's for disjoint events. So disjoint events happens, as a reminder, mutually exclusive means that intersection or overlap is empty, so the probability of that is 0. Or in other words, we don't have to worry about any double counting in this case. So keywords here are still or at least 1. And again, this only applies to the very specific setting of disjoint events. And that rule is going to change just very slightly. A or B. Again, or because we're doing at least one or. We're going to add the two together. And then we're done. We don't need to subtract the overlap because there is no overlap when our events are disjoint. So there's our next formula. Let's just do one example from our coin toss setting. So for this one, suppose I had event A, which was tails, tails. I have event C, which was heads, heads. And I've got the other outcomes here, heads, tails, tails, heads. And if I'm curious, so these guys are clearly disjoint. There is no overlap. There are no common outcomes between the two. So probability of A or C is the probability of A plus the probability of C. I don't need to worry about subtracting any overlap from double counting. So A had 1 out of the 4 outcomes. C had 1 out of the 4 outcomes. So we get 1/2, which makes sense. A and C together have 2 out of the 4 outcomes. Now this last one is this idea of multiplication, and I really want to emphasize, put lots of exclamation points here on this criteria. This only works if our events are independent, meaning one event does not influence or impact the next. Just like tossing a coin, one coin toss doesn't influence the next, or rolling a dice. Here, let's put our keyword multiplication rule associate with and. So or goes with adding, multiplication goes with and. And this most basic rule here, under this very, very special setting, independent events, is the probability that both A and B happens. Again, multiplication rule means and. So A and B is found just by multiplying A, probability of A times probability of B. Really simple rule, but it's one of the ones that's most often misused because it's so simple. You can only use this if you know for a fact one event doesn't influence the next. So in our example, suppose I want to know the probability that the first toss I get heads and the second toss I get heads. Well, I know one toss does not influence the other, so I can just multiply these two things together. Probability of getting heads on the first times the probability of getting heads on the second. So getting heads on one toss is 1/2. Getting heads on the second is 1/2. So that gives me 1/4. Which makes perfect sense with what we saw. If you remember, out of our 4 outcomes, one of the 4 was heads, heads. All right, next video, we're going to put some of these formulas together into practice, into some different examples.